So there's a lot of examples that we will go through in this video, but you can download the project files and learn from them at your own pace. So we'll go through Houdini first. So you have the meshes and for this building, and as you can see we have the 2 detail levels and they're made procedurally. So we can look at this example first. So we have, let's say, this column and a bunch of other things on top of it, and at the end we select these groups and we give them different materials. So each one of these colors is a different material slot. So when we get this mesh into the engine, so we have this mesh and it has 1, 2, 3, 4 materials. And in the graph, we can override these materials. So all of this stuff here is material overrides. And it starts with the material and then material underscore 1 and then material underscore 2 and material underscore 3. So all of these are data assets that hold different materials, and these different materials can override specific materials on a mesh. So this is why when I turn this on and look at it in the viewport, we can see that the corners and this part here are overridden. So if I, for example, switch this to, let's say, blue, and since all the material slots in the data assets have the same material, all of them switch to blue. But if I switch this specific one to green and I look at it here, we will see that this M3, which is the orange here, switched to this greenish yellowish color. So as we can see, we can override materials with the Alembic workflow in the same manner we did with meshes. So this was the workflow for meshes. Instead of the struct holding static meshes, it's holding material instances. So in here, this is holding static meshes, but this is holding material instances. And the struct is right there. It's material instance and it has the integer number for the material underscore ID. And as we can see here, the same struct is being used over and over again, but for material underscore 1, 2, and 3, we're just renaming it. So instead of material here, as you can see, it's being switched to material underscore 1. This part here, the renaming of the attribute, is just so that we can avoid having to duplicate this struct multiple times. And because since it's the same struct, the same material instance with an integer, we don't have to duplicate it. All we have to do is just rename it so that we can use it here in material underscore 1, 2, and 3 for the different slots 0, 1, 2, and 3. I hope that makes sense. I'm gonna keep moving because we have a lot of things to cover in this video. So as we know, Houdini can take like something like a tube and then divide it into these classes here, and then each one of these would get switched into this extra detail because, for example, we go through here, add some edge damage, some boolean on the sides with something like lines here getting cut out, and some bevel and VDB, and at the end just reducing the poly count. And it's not clean. You can take more time and do like a high poly, low poly, and bake that. But for the sake of this example, we just had to do something really quick to show the workflow. And as you can see here, we give them different, these meshes have different groups, and the groups go in the this material slot which all it does is give this shop underscore material path a name, and that is what you will see in the engine when the material slots are created. So now we know how to get the mesh in and the material slots to be overridden in Unreal with the Alembic workflow. If I turn this off, turn the other one on, this will show the same result but without the material overrides, because this does not have the material overrides. Okay, and in here, as we know, we can always come here and change the data asset to spawn the one we need. Okay. So the first part here at the top is the example we made in the previous video. I just switched the meshes to be something more presentable so that we can see what's going on. And this is the Alembic workflow using this data asset with these meshes. And if I switch that off and switch the CSV on, it should look the same. Yes. And as you can see, we're spawning the same meshes here with that grid example. And they're all included here in the same project file. Okay. The detailed building here is also using this CSV workflow, and it's included here. And this is just a quick example here how we can delete attributes, deleting material attributes, and the overrides will go away. Or you can just turn that off here. Okay, and another example here is spawning them on a grid. So we have this grid here, and the same building gets spawned onto multiple points. And what you could do is you can have multiple data, like point clouds, and then the building gets copied to another point cloud here that goes into the target instead of copying it to a grid. Just a workflow that you can start compounding things on top of each other. Okay, street actors. So this one is spawning actors instead of meshes. So all of these mess here, it's a bunch of different prefabs that are being spawned on a street. And as you can see, I'm using the building meshes and I'm mixing them with the Lego ones and putting them on the street actors all together. So you can't see anything here in the meshes because it's only spawning actors. So this is the list. So switch to actors is on, and this is the copy to reference. So we can see how these actors are made like that, and then you do the copy reference and that goes into here. Okay, and the way you make these actors, they are packed blueprints. So if you have a bunch of meshes in the viewport and you right click, there's level, and then there's create packed level actor, and then that would give you a blueprint here like this. So it has to be a bunch of meshes in the viewport, and then you make this from them. And all of these would be references to be spawned either here, or we can see the same result all the way down here. Right there. So we're spawning it on a different point cloud, but it's spawning the same prefabs. And this is an example which we will go into in a second. So I switched this to the 0 prefab, and as we can see, we have the same street formation. So this attribute filter is filtering out this curve attribute, which I defined in Houdini. So, and this says Houdini here. But if we go into Houdini and we look at the street, this is the street, and when I exported this with the city, I exported them all on top of each other. This was just a test to see if it's possible, and it is. So each one of these layouts have this curve attribute, curve 0, 1, and 2. And in the engine, we use an attribute filter, this attribute filter, and it's filtering out this curve. And the one with the value 1 is this curve, Houdini. And it's spawning the paths, the actor paths, and that is here. It's the same process we did with this, make a struct, but this time the struct is not static meshes, this time it's prefabs, which is like actors, blueprint actors. So in the engine, if I go to the struct of this data asset, we can see it here. So it's a string and an integer. So all we need is a string, because we can paste this copy reference of an actor into a string in here in this data asset, and the data asset is being used in here, match and set like usual, and we spawn the actor. So this is the Alembic prefab workflow, similar to what we did in the CSV here, but here it's all included within the blueprint itself here in this list. And the index here matters, so 0, 1, 2, and so on. But in the this Alembic workflow, you can swap, for example, the 0 to be here and the 1 to start with this. So the order doesn't matter as much as in the CSV blueprint. Right, the Lego example, let's look at that. So do I have any other thing that you wrote? Yeah, let me just turn this off. Okay, so where is it? Okay. So this is a example just to show that the material overrides work, and you can have lots of them here. So we have the Legos, these two Legos, and the material overrides for the Legos. So these are all the material overrides, and it starts with -1 because sometimes we don't want to switch the material, and if the attribute is -1, then there's no material override and it doesn't switch it. So in Houdini, we can look at the, and as you can see here, it's just totally different colors, but you can try to match it if you want, but you don't have to. All it does is it's giving it different attributes, and the attributes are being overridden here with specific materials that you decide in the engine. So how do we start with this? So we have this geometry with the pig. Just get some subdivision here, and we get this point cloud using like points from volume, and then like overlaying some of them on top of each other, giving them this mesh ID 0 and 1 for the top ones, because I want the top ones to be this pyramid thing, and bottom ones to be the cube, and then different groups, and each one of these groups will get a different material. So material 0 is being initialized here with 0, 1, and 2 for each one of these groups, and that's how we can get this visualization here to work. It's similar to, for example, here, if I switch to the simple version and I turn this visualizer on, I can see how we can change these values here. It's similar to this, what we were doing here with adding a material and giving it a value, but it's all happening within this one node here, and it's doing it automatically. And that's gets exported with the Alembic, and of course we get it here, and we override the materials here. If I turn this off for a second and I look at it, we can see that it's all red, but if I turn the material overrides on, we can see that it's following this list of materials. Okay, and one more example here, like abstract black and white example of the pig. And it's same thing. We have this list of meshes and a list of materials. And now we can start to see it. There's a pattern here, like we're overriding materials and overriding static meshes. And in this case, it's the materials are different grayscales of values. And in Houdini, we can look at it here, and we can see if we go to this, just to match the idea there. Okay, so the meshes are, they have this IDs 0 and 1, and copy the points, and we pick this like ambient occlusion thing, and we get the colors to represent the materials. Okay, and lastly, the city example. So let me turn that off first. Okay, look at the city. Okay, and what we could do is we can also look at the pipes. So in this case, the pipes and the streets were modeled in a way that the start and end are exactly lined up with both. So this way we can easily swap from streets to pipes and back and forth. It's the same thing. We're spawning mesh and material attributes. This is the material overrides, which we did cover earlier. This is the mesh overrides. And as we can see here, there's the list of meshes. And you can make them look much better, of course. This is just a proxy. You can make them look like an actual street, or it could be like an indoor corridors or a level, like whatever your game is supposed to be. In Houdini, the nice thing about it is that we can do things like go in here, and I'm just gonna show this part here and look at it like that, and keep creating more things like that. So once I'm happy with the layout like that, maybe I'll add these as well, and then export it with the Alembic. Go in here, and then simply update the seed, and we should see the extra part that was added up at the top here. There. This street example is more complex, and you can dig into it on your own. You can do other things like spawning lot subdivisions on like the sides, and maybe spawn things like street lamps and other things. And there's mesh and like other overrides, which for example, let's say we have corners like that, and you want them to be something similar, but specifically here, this is an example where what we could do is do things like we have a point that can hold a value for a different mesh and that mesh can override the current meshes with that like proximity. So this has this value of the other mesh, and it feeds into this subnet here, gets the mesh variation with the proximity, and overrides the meshes and the materials needed. This is a bigger example which you can dig in on your own, but as you can see, you can start building, you know, how Houdini builds bigger and bigger cities and structures like that, and automate the level building, and then you export the layout, and in the engine this is what you have, and the artists can simply swap the meshes and you have a full city generated within seconds. So that's all I wanted to go over in this video. It's a lot, but I'm excited to see what people will create with this.